On the repair bench today is this Wavetek 5 MHz signal generator. It's model 184. I'm absolutely certain it isn't working, but I'll take a double check just to be sure. So I've got it plugged in, and there's a small signal coming out onto the scope, but this scope is set to 10 millivolts per division, and there's just kind of this messy waveform coming out at 100 Hertz. Which is of course double the UK mains frequency. It doesn't matter what I change, this is all we get all of the time. The controls have absolutely no impact on it whatsoever, so definitely a dead machine. This is the TTL output, and of course it should be a nice square wave, but it's got about, I think, 35 millivolts peak to peak, something like that. It's bloody awful signal, and certainly not TTL. Just 4 old-fashioned Phillips screws. Seems to be all that's holding it together. See what happens. Yeah, we're in like Flynn. Okay, here we go. So I haven't taken the bottom off yet. Let's see how easy that comes off. Someone's obviously had a good go at this in the past. It's got non-matching screws in it, so a giveaway. I wish all devices would come apart this simply. Okay, so we've got a little piggyback board on the back here. Well, piggyback, upside down piggyback board on the back here. Transformer. Voltage selection fuse. So we know that's all right. This is the sweep start stop, sweep time, and sweep width. Well, I'm going to leave that board alone for the time being, because this is clearly the sweep control board, and yeah, I'm going to leave it alone unless I have to do something to it. We've got a CA3130. That'll be that's a op amp, isn't it? As far as I recall. So 7805 power supply there. I'll check that, because who knows. Tip 29, tip 30. So this is apparently the hysteresis switch for the sine wave. We've got a pulse generator over here using 7/4 logic, 5-volt regulator, preamp over here. Yeah, there's plenty of places this could be going wrong. Output amplifier, of course, sine converter, and I didn't see any frequency change on this at all, so yeah, let's start with the raise the power rails, and then we'll go from there. In the meantime, I'm going to go and find the service manual, I hope. Great, I found the service manual, and as of most pieces of equipment of this age, it's a lovely service manual, troubleshooting sections, calibration sections, and yeah, running through, and yeah, plenty of full circuit diagrams. Now, I'm not going to get too involved in those for the minute. This is the one that I want, and that indicates that I've got a plug here with all the voltages on that I'm interested in. Okay, so this plug is actually on the back, just here. The third one is ground. So pin 9 is supposed to be 15 volts, and we've got 3 volts. Okay, well, this is a good start. It's supposed to be minus 15, and we've got minus 3. Cool. What we've got next, we've got another ground, and then pin 2 is supposed to be 5 volts, and we do have 5 volts, so that's something. But plus minus 15 is simply not there. 3 and minus 3.8. So yeah, so I'll need to trace that down then. Oh, let's just hope it's just the power supply. That would be amazingly helpful. Okay, so I've disconnected the power supply from the rest of the circuit. So there's a couple of jumpers here which enable us to do that, so that's good. And there's a plug on the underside of the board as well, which feeds that daughter board that we saw, and that actually takes its power direct from the power supply side and not from the other side of the jumpers, which is a bit unfortunate, but I've been able to just unplug that. So I'm going to test the voltages now. So this will narrow down whether our problem with our power supply is in the power supply or whether it's a problem elsewhere. So probing pin 7 of the 741 op amp, turn the power on, and I've got 15.00 volts. So that's pretty good. Let's probe pin 4. I'm probing left-handed here, this is really awkward. And there's our minus 15.01, so that is absolutely bang on. And of course our 5 volts was there present on the other side. So what I'll do now is I'll just plug in the daughter board again and just see if that gives us a voltage problem. So I kind of hope it does, really, because it'd be really nice to narrow this problem down, because so far we have eliminated about 4 square inches off the top corner of the board, which isn't great really, but anyway. There's 15. There's minus 15. So okay, so it's unlikely to be a problem then on that daughter board. Let's see where else we may have a problem. Oh, this could be. There are hundreds and hundreds of components on this board that could cause this problem. I suspect potentially the output section, because that has plenty of current capability. But if a component is drawing enough current to make these voltages collapse on the power supply, then one way that we can track it down is to actually use a desktop power supply in place and stiffen up the current provisions. What will tend to happen then is that the components that are causing the problem, or at least the components around that, will tend to draw a lot of current and therefore get very, very hot, and that will help us find them. It's a bit nasty, a bit quick and dirty, but it should do the job for us. And we have smoke coming out of a couple of the devices over on the left hand side. So one of the resistors over here, certainly, and another one over here. So that very, very much tells us where problems are, and they are in excess of 150 degrees all around that part of the circuit. So we know we have our problem narrowed down. So yeah, all around here, which I believe is the output amplifier. Whew, yeah, we've got some very burned looking resistors there now. Zoom in a lot more, but I'll do my best. So here we go. So hopefully that's good enough. So this resistor here is looking very, very badly burnt. This one here even more so, and I think actually this one down here actually overheated quite a bit as well. So we can imagine fairly simply there could be problems around these transistors, although they didn't get quite so hot. It was mainly these resistors here. Problem that we have now. So I've highlighted the resistors that were affected. So at the top we've got the 10 ohm that smoked, at the bottom we've got the 10 ohm that smoked, and we've got the two 8.2s that I said got hot in the middle, and we can very clearly see they are on the final transistor output stage. So how could that happen? Well, probably our top candidate is one of these two transistors is faulty and allowing current to flow. So let's say that happens. Let's say that this bottom one is faulty and allowing current to flow. Then when this transistor at the top gets turned on, instead of coming through an 8.2, a 100 ohm, and going up here to a 50 ohm load, which will be loaded to ground. So that is what? That's 50, 150, 152, 158 ohms. It's instead going through a 10.8 ohm route, and not to ground, but to minus 15 volts. So that gives a lot more current than we would be expecting through that transistor. So that's our first thought. Now, normally in normal operation, when this transistor at the top is conducting, the transistor at the bottom is not conducting. So you know, we wouldn't normally be following that that route. Now there are some routes back through higher resistances that are going to ground, so we can see all the way back through here. So there is a route back to ground for the emitters of those transistors, but they are through quite large resistances. So 3.3, I mean that 1k could be anything. That's 820, so let's call that 4.2. Yeah, so 4.2, 4.4k of resistance. Now there's potentially we could have a fault to ground somewhere is another thing that instead of these transistors. So for example, on the attenuator, either of those two resistors there could be a fault on this switch up here. There could be a fault on the actual output, but you know, we're getting into less likely territory there. So I would say there's a 70% chance that one of these two transistors is faulty. So here are the two transistors, and I pulled them both and I put them both on the tester, and they are both dead short across the collector emitter. Now that was a bit of a surprise. I didn't expect them both to be short, just one, but I guess the amount of current is right up at the limit, and if it lasted just a bit too long, or the event that caused it was a bit more traumatic, then that would be the end of these. Yeah, I had kind of expected one to have gone, but two was a bit of a surprise. Okay, so this is kind of the moment of truth. I have replaced the power links over here. I measured it as drawing just about 100 milliamps. I decided that was probably okay. So that was without any transistors in the, or the two output transistors in the output amplifier. Okay, so that's fine. I've reconnected it and we are holding the 12 volts that we should be doing. So that's all good news. So now we need to have a look at our output. Now what I've done with the output section is I've actually moved Q32, no that's wrong, Q34 and Q35, which are the same parts as the output amplifiers, up and put those on the output. I had a quick look at those on the meter and they both tested okay, so I've done that. And then I've put a BC 340 and no BC 640 and a BC 639 on the prior stage. So let me just pop that on the screen so you can see that. So yeah, so this transistor here has gone down here, and this transistor here has gone up here, and then I've put BC BC 640 and a BC 639 in place of these lower power transistors. Okay, let's see what it does then. So here's our scope. So I've got a 50 ohm load on the scope, which is supposed to be, this is 50 ohm output. I've got 0 dBs of attenuation, and I've got the twizzly bit, the variable amplitude turned up full. So this is running at our highest possible output. I've got a sine wave without offset set, and I've got 0 offset. I've got constant. I have not yet reinstalled the sweep board. I've got symmetry set to normal, and I'm going to run on times 1k, and I'm going to set the vernier here to 1 or thereabouts, whatever I can get away with. There we go, 1. I reckon that's a 1. All right, let's power it on. Oh, look at that. Absolutely perfect. So let me just see if I can find the counter, put that onto channel 2 so we can actually see what frequency we're running at near enough, and that is 1.01 kilohertz. So we've we're within about 1%, so that's pretty bloody good. Let's turn this, yep, okay, and I'll just turn the time base a bit higher. That is a nice sign, and it's adjusting nicely with the vernier adjustment. I'm going to turn that all the way up to 5 or thereabouts. It's a bit difficult to see from this angle. And yeah, that seems to be looking good. We have got 4.996, so that's about 0.5% off. So that is pretty damn good. Okay, let's times by 10. Yeah, 50 kilohertz now instead of 5. I'm going to have to keep changing my time base on here. Yep, and we've now got 500 kilohertz, and we turn it up to this one, and we should be at our max 497. A little tweak, yeah, 5 megahertz. There we go. Right, okay, so that's pretty nice. So if I turn the symmetry on, yep, then it's supposed to divide the frequency by 10, sorry, which it has done. We're now at 500 kilohertz, or a little bit more actually, but near enough. 529, so it's not quite divided by 10, I have to be honest. I'll change, there we go. So we can now see the, yeah, symmetry effect. I run out of symmetry at just this end here. So that might just be mucking the control, or it might be just allowing it to go beyond its limits. But yeah, there we go, nice. Okay, let's try the other waveforms. So this is supposed to be a triangle. It's not great, I suppose. I'll turn this down a little bit so we've got a slightly lower frequency. I'm going to turn it down to 20 kilohertz thereabouts. Because on our top frequency we would expect a tiny bit of rounding and overshoot on square waves and all that sort of stuff. So I'm just going to test this in its middle frequency range, so that's really nice. Square, and I've got, let me have a look at the voltage. Plus minus 5 volts is what I've got on my output. Very nice indeed. And that's on its full thing, so that's a 10 volt peak to peak, which is exactly what we'd be expecting to get from this. Bloody good. Let's turn it down. Yeah, so we can see that works beautifully. And let's attenuate it. And of course that's going to be a bit of a problem for us. Let's, and there we go, that's a 20 dB attenuation. We're picking up noise now on the 40 dB attenuation, a bit of noise up here. So let me just turn this, talking about noise. Oh, that's better. So that noise in the background was my desoldering station. Unbelievably noisy, I really need to try and do something with that. But there we go, yep, lovely, lovely square wave. Let's change to with 40 dB, bit of noise as we say, so I'm expecting to see even more noise on this setting. And truthfully, I'm not really feeling a huge need to attend to that noise very much. But yeah, there's some very, very high frequency noise on there. Truthfully, it may just be a case of, unfortunately, some common mode noise. Let's just touch this cable. I haven't used this particular cable before. So they're at tens, it looks like it's well over a megahertz. This is 2 milliseconds, 2 microseconds rather, sorry. 1 microsecond. So we've got about 5 cycles within that. So yeah, there's a good chance it is just common mode noise off the power circuits and things like that from all the switching power supplies and things that we've got in this place. So I don't know what the noise specification is for this. I can look that up later. I could be chasing my tail trying to fix something that doesn't really need fixing. Okay. So yeah, what's next then on our exciting thing? So our next one is so this is a DC pulse. This is a positive DC pulse. And yeah, we can see that we've got our 0 volt in the middle and we've got a positive pulse going above that line. And I'm going to just pull it in a bit, change the symmetry. So pretty good, happy with that. Let's turn to the other pulse, so it should be below the line, which is, so just need to trigger, thank you. And again, symmetry should do the opposite. Excellent. What have we got next then? So we've now got offsettable signals. So we'll put our vernier round about center. pretty good. It just needs a very slight adjustment there, I would say. Just for me, that is centered, and I'm fractionally off center with the knob, but you know, truthfully, that's probably just a case of aligning the knob correctly rather than anything else. But as we can see, we can go up and down. Now I am at the maximum output, so we are obviously very quickly. So I'm at 2 volts per division. Yeah, and look, it's clipping just here, obviously, and clipping down here, obviously. But if I turn it down, I need to follow it with the... Then we can see we can go up and down within those limits absolutely fine. So that seems to be working perfectly. Go for a triangle, do the same thing. Yes, we can. So that's fine. Yeah, just losing my trigger, that's all, because I'm moving in and out of the range of it. Yeah, nice. Square, same. Excellent. And a DC. And excellent, we can move that around. So the DC is helpful because it enables us to set the 0 volt point very accurately. So that is absolutely great. I've got this outputting maximum power into 50 ohms. I've got no temperature on any of these components. I have replaced the 10 ohm resistors, of course. I have replaced the 8.2 ohm resistors as well. And I've put 0.6 watts resistors in for those because that's my standard resistor. And I'm very, very pleased with that. I'll just check the TTL output. Okay. Oh yeah, okay, so my TTL is going out into 50 ohms, which is why it's low. If I take the... there we go. Yeah, so 5 volts per division. Let's try and trigger on it better. Yeah, there's what we often see here with TTL, unfortunately, which is this very, very nasty undershoot. I mean, basically this is coming out of a 7400 over here. I think just because I would like to maintain the original parts within this, that I will get hold of a couple of the original transistors, so we've got 4 of those original cans with their heat sinks in there. So I'd hope we might have finished there. I have replaced the sweep board for the moment. You can see that in the front here, and connected that up. And yeah, I am not, I don't think, getting a sweep from it. Okay, so I've clipped my scope onto the ground and the sweep output from the sweep board, and as we can see, so in sweep start I am at minus 2 volts. At sweep stop I'm at plus 2 volts, so we'd expect that because we're just outputting the 2 ends of the sweep. And then in continuous sweep, nope, we've got nothing, we're just sitting at the bottom. Our most likely candidate then is almost certainly the op amp. There's a couple of things I can look at on there. So first of all, I need to find the circuit diagram, but I'm expecting that pin 2 and 3 on the op amp should of course have the same value on them, and if they don't, then we know exactly where we are looking. It may seem a bit strange, but it's really annoying when an electronic circuit just starts working all on its own. So I decided to have a little probe around on the board, and I needed to check a few things like the pins on the op amp, and I wasn't sure what was what, so I decided to start with the power rails. And there should be a minus 15, minus 10, I think a minus 5 and a plus 15, or it might be a plus 5. But anyway, the long and short was I found the 15, but I didn't find the minus 15, and the other negative voltages were also incorrect, which meant there must be a fault in the onboard regulator, because this takes plus minus 15 and 5 in and does its own regulation for its own purposes. So I started probing around the components for that, and all of a sudden I had the voltages that I wanted. So that's probably typical of a loose circuit connection on the back of the board somewhere, maybe a cracked component or something, but very, very annoying. And of course I couldn't get it to go wrong again to narrow it down. But anyway, there we go. On our scope we have our working sweep visible. We can see that right there, going from a high frequency to a lower frequency and back up to a high frequency again. So I need to do a little bit of work to consolidate this board to make sure it doesn't go wrong all over again. What I'm going to do is I'm just going to replace all of those capacitors. I'm going to solder lots of the connections again on the back, just in case there's a poor quality solder joint, and fingers crossed that will do the job. So I have replaced all of the three capacitors on here. These were the original capacitors. These are 100 microfarad 16 volt electrolytics. Now this is a 15 volt supply, so 16 volts is cutting a bit fine, truthfully. I've replaced those with 25 volt 100 microfarad, and these are Rubicons that I've replaced it with, so nice quality capacitor. The next thing that I did was I actually resoldered all of the connections for all of the power section. I also replaced a couple of 0.1 microfarad capacitors that were over here, and the reason for that is they were physically quite badly bent over, so I decided that it would be sensible to replace them. They may have been physically stressed. I resoldered all the connections for this connector on this side, of course, as well, and just cleaned that. And cleaned all the controls as well. And I've reassembled it now, and let's switch and just see how well it is performing. So here we go, front view, and the panel's nice and clean now. I've ultrasonically cleaned all the buttons and knobs and everything, so it all looks a lot nicer, and I've cleaned all the controls on the inside. I've also cleaned the BNCs, and there's another little video, a little tips video that I've put in just to show how I do that. If we look at the scope, I have a sweep signal running at the moment, and you can see that its frequency is kind of doubling over time, and it's centered around, it starts at 3 kilohertz, and it ends at about 5.5 or something like that, and it's on constant sweep, and it's a square wave, so absolutely great. We can of course do that with a triangle wave as well, and a sine wave. And that's it. Gated mode, yes, that works. Just press the trigger button to test that. We could feed in a signal down here somewhere for the gate and the trigger, but trigger mode is harder to test because it's hard to catch. It's only going to do like one cycle, and it's very hard to catch that on the scope. We might be able to just run that in single. There we go. So there's our trigger, a single cycle, very nice. And I'll put this back into constant now. Put this back into run. And there is our nicely variable frequency. We have a calibration button down here which makes minor adjustments to it. So if we think that should be 3, then yeah, we can adjust that by very small amounts. Okay, so there we go. Basically working. Sweep start now behaves slightly differently if I put this onto sweep mode. So I can dial in a start frequency. So if I dial in, let's say 2. So 2 kilohertz, and then I switch to stop, and we can then use the sweep width to change that. So I'm going to go for we're at its limit. So I'll go for 5.5-ish, something like that. There we go. That's near enough, 5.5. And then of course we can switch on to constant sweep, and we get the sweep that we've programmed. But the sweep start earlier was moving around as I was changing it. Since I fixed the board, that's no longer happening. I can set the frequency on here and rely on that to be the start. So there we have it, all cleaned and reassembled. and I'll just connect it up to show it working again, but we are basically done. So all reconstructed, has the normal, a bit of the normal signs of age, although I've cleaned it quite a lot. There are a few, from certain angles, there are a few visible marks on the top where people have had things stuck or standing or whatever, I think. But overall, I'd say it's in pretty decent condition given its age, and operationally, of course, it's working just fine. So anyway, that's it. If you liked this video, if it was helpful to you, please give it a thumbs up or like it, and of course subscribe if you haven't already done so, and please leave some comments down below. Happy to see them. See you soon. Bye.